Flexscan application video. Phased array operation. When we make a new configuration, we first reset config. Next set up the wizard. Create a new group. Set the characteristics of workpiece, geometry, thickness and material. This thickness is very important and needs to be known when inspecting the weld on site. You can click the keyboard at the top right of the screen to enter numbers, or use the shuttle to adjust the number to 10. Group mode option, select PA. Connection P remains 1, where the first transmitting element is connected. Select the corresponding probe on the probe selection page. There are two options under Select, submenu, select TX and Defines. You can choose probe and then select the probe from the list. If your probe is not available in the list, you need to define it. After customizing the probe, you can select it from the user probe library next time. Then select wedge according to parameters on the wedge. Scan offset, index offset and skew will be set later. Next, set law wizard. This time the type of scan is sectorial. Set focal type to true depth and wave type to shear wave. Focal depth is usually set to 1.5 to 2 times the plate thickness. This time is 1.5 times 15 millimeters, and the focus is setting in the middle of the plate. Element quantity is quantity of elements used for each ultrasonic beam. According to the probe and equipment, this time element quantity is 32. The angle range is generally a plus or minus 15 degrees of the wedge physical refraction angle. The angle this time is 55 degrees and the angle range is set to 40 degree to 70 degree. Click to generate focal law. Next, calibrate. Select calibration menu and choose ultrasound type. Mode options includes velocity, wedge delay, sensitivity and TCG. When the sound velocity of the material is known, we can input the sound velocity directly without calibrating. Velocity calibration can be carried out when the sound velocity is unknown. Select mode as velocity and click Start. Use the two arc surfaces of R50 and R100 on the test block for calibration. Place the probe in the center of the arc. We observe in the scan area. If only one echo is found, we need to increase the range until to see the echoes of R50 and R100 at the same time. Echo type, choose radius. Radius 1 and radius 2, enter the two arc radii of the test block. Adjust gate start and gate width to make the first echo in the middle. Move the probe left and right to find the highest echo. Then get position 1. Keep the probe still and move gate to cover the R100 echo. Get position 2. If the velocity is within the normal range, click Accept to complete velocity calibration. Delay calibration is used to correct wedge parameters after wedge wear. New wedges do not require it. This calibration generally uses small holes. For example, CSK1A test block has a 1.5 15 mm deep hole which can be selected for calibration. Choose wedge delay. Echo type is depth and enter the depth of the hole. Place the probe over this small hole. The echo signal can be seen on the left side of the screen. Set gate to make the echo in the middle. Gate threshold is set to 15%. Clear envelope. Move probe. The instrument will record the depth of the hole collected at each angle to form an envelope. Click Calibrate button after the delay envelope is completed. Sensitivity calibration is to compensate the gain of the angle at a fixed depth. TCG compensates the gain of depth and angle at the same time. Generally, when the thickness of the workpiece exceeds 10 mm, we need TCG calibration. Choose TCG mode. Reference amplitude indicates the height of the echo. Tolerance is the error range of echo height. Generally, parameters remain the default settings. 20 mm thick plate is used for this test. The range of hole depth shall be less than 20 mm at least and more than 40 mm at most. The CSK1 test block has the influence of end angle echo when calibrating TCG with phased array. When the hole depth ranges from 35 mm to 40 mm, echo interference is serious. This demonstration only makes TCG curve to 30 mm depth. If other test blocks are used, make TCG curve completely. Look for a 15 mm deep hole first. After placing the probe over the hole, move the probe left and right. After finding the small hole echo on the left side of the screen, adjust the gate so that the hole echo is in the middle of the gate. The echo of the first hole shall not exceed 2 green lines. If the green line is exceeded, reduce the gain. Click Clear Envelope to recreate a new curve. After completion, add points to make the next point. For the next point, we use 20 mm deep holes. Place the probe over the 20 mm hole. Similarly, find the hole echo in the left area. Adjust the gate so that the echo is in the middle of the gate. Move the probe left and right. If the echo height is found to exceed the green line, the gain cannot be adjusted at this time. As long as the echo height does not exceed 150% of the full screen, the instrument can be calibrated. After the probe moves back and forth several times, observe that the envelope is smooth and add point. Other deep holes envelopes are made in the same way. Click Accept at last and TCG calibration is completed. Next, set sensitivity. Select 2T settings. Open decibel reference. A bracket appears for the reference gain in the upper left corner. Click Set Reference. Then the basic gain of TCG will put in bracket. Select General. Increase the reference gain to 8 decibels, where 6 decibels is the additional scanning sensitivity and 2 decibels is the coupling compensation. The coupling compensation is generally 2-60 dB according to the workpiece condition. Choose Display ASC mode. Open C-Scan 1 and select A%. A% means that the data recorded by C-Scan is the highest wave in gate A. Next, simulate the weld. The workpiece is butt weld. Click Butt Welded Joint. Turn on Weld Show. Set the parameters according to the actual workpiece weld. After setting, the weld structure diagram appears in S-Scan area on the right. Next, set probe's placement position, open position, index offset, adjust index offset, the distance between the leading edge of the probe and the center of the weld. Place the secondary of the weld in the inspection area, under the condition that the full coverage of secondary echo can be guaranteed. Let's try to sweep more roots at a time. Next, set gate. Adjust the starting point and width of gate A, so that the secondary wave is in the middle. Gate threshold is set to 20%. Next, set gate B. Gate threshold is set to 40%. Change field. For to dBdB, this value represents the equivalent SL plus decibel of the defect evaluation line. Result 3 is VIA, distance from defect to weld center. Result 2 is DA, defect depth. Set scan source as encoder. The resolution of this mouse encoder is 67. Set scanning area. The length of this sample is 300 mm. We set the scanning range a little larger, 350 mm. Adjust the pulse repetition rate to the maximum. If the scanner speed exceeds this data, there will be data loss, black line. Save profile. Adjust the range to enlarge the detection area. Set the position to start scanning. Index offset is 12 mm. Place the probe 12 mm away from the weld center. Due to the width of the encoder we can scan from the starting point, we need to measure the position of the encoder. Measure from the center of the probe to the edge of the specimen. This measurement is about 35 mm away from the starting point of side A. Press the Start key to scan. Save data. Next, the scanning will be carried out from side B of the weld. We need to change some parameters. Click Skew. Change skew from 90 degrees to 270 degrees. Change index offset to positive. Press the Start key to scan. If the data acquisition direction is opposite, reverse the encoder polarity. This measurement is about 30 mm away from the starting point of side B. Press the Start key to scan. Save data.
Audio Jungle.